It's a great pleasure to receive Professor Amitabha Ghosh at IIT Kharagpur, and it's nice to see such a interesting audience also. Just to introduce to the audience, Professor Amitabha Ghosh was born on 3rd December 1941 at village Bahra of Birbhum district, West Bengal. After completing his schooling at Bahra High School, he did ISc from Suri Vidyasagar College, which is part of Calcutta University, in 1958. He received his bachelor's and master's degrees in mechanical engineering from Bengal Engineering College, Shivpur. Now it is IIEST. That's in 1962 and 1964 respectively. He joined the mechanical engineering department of this college as a lecturer in 1965 May and continued his doctoral research, finally receiving the Doctor of Philosophy degrees from Calcutta University in 1969. Thereafter, he joined at IIT Kanpur in January 1971 as an assistant professor of mechanical engineering and became professor in 1975 June, within 4 years of time. From 1977 to 1978, he spent at the Technical University Aachen with Alexander von Humboldt Foundation Fellowship. From 1997 to 2002, he served IIT Kharagpur as the director and subsequently returned to Kanpur, where he continued teaching as professor till his retirement in 2006. Afterwards, he was a senior scientist at Indian National Science Academy, New Delhi, and honorary distinguished professor at IIT Kanpur and Bengal Engineering Science and University, Shivpur, till 2011. Currently, Professor Ghosh is a Platinum Jubilee Senior Scientist of the National Academy of Sciences, India, and an honorary distinct professor, Department of Aerospace Engineering and Applied Mechanics at Bengal Engineering Science and University, Shivpur. He also invented a number of new drive systems and mechanisms and conducted original research in the area of kinematics and dynamics of machines. He has published over 120 research papers and written 5 books. The textbooks by him have made a lasting impression on the way the subjects are taught in India and also abroad. Professor Ghosh got numerous awards, so it's a very big list. Skipping that, other activities by Professor Ghosh: writes articles in Bengali for magazines like Desh, Anandamela, Hruday, etc. His 2 Bengali novels have been published by Desh Publishers and Sahityam. He has interest in sketching, portrait drawing, and classical music. He also plays pakwas. It is my pleasure to invite Professor Ghosh onto this stage and let us listen his beautiful lecture. Thank you.
Raja, for the absolutely unnecessary introduction, because I find that this ritual is very old and ancient, because when I am not an applicant for any job here, why the biodata? So, I think this talk is primarily meant for youngsters, and it is one indication that how I want to emphasize that in science, nothing should be considered as final and the end of everything. And I also wanted to show that how the teaching of undergraduate program may lead to new ideas which may sometimes be very useful and productive. So I think I have taken a topic which I think is familiar to all of you. I want to go back to these Newton's laws and show you, particularly actually I expected more of schoolboys and girls rather than matured physicists, that generally the way it is considered as gospel truth, it is not true. So this lecture is aimed at impressing upon the student and research community that there exists always scope for improvement upon the existing established framework, which I think is generally agreed upon. And in this lecture, we take up 2 most fundamental aspects of physical science: inertia and gravitation. See, gravitation and inertia are 2 most profound phenomena, you all know, which control the affairs of the whole universe. And without understanding gravity and inertia, it is not possible to understand the universe. But till today, the understanding of these two phenomena are far from complete. We have wonderful theories like general theory of relativity and such, but still, understanding is really not absolutely complete. Say, this is one of the laws which I'll take up, where you are taught in the school level that force between two bodies is equal to G into M1 by M2 by R square, the apple falling towards Earth, all those kinds of things. And another quantitative law which is familiar to us is force is equal to mass into acceleration. These are the two laws I'll take up and discuss. The points I will present will be what are the unsolved issues in these Newton's laws within the framework of Newtonian mechanics, of course, and what possible modifications may lead to some useful final result and understanding, and what may be the consequences of these results, very interesting consequences. So you all have heard about Sir Isaac Newton. He was born 1643 and died 1727. He had a very long working life, like poet Tagore. Newton's laws, as we are taught in schools today, that if there is an object of inertial mass mi and we apply a force F, it accelerates at the rate A according to this law. Force is equal to inertial force mi, the subscript I you should note, and the acceleration. The other law says that if there are two objects with gravitational masses, say in case of Earth and the apple, the gravitational mass of this Earth is mg Earth and this is mg apple divided by the distance square into g. So this distinction between inertial mass and gravitational mass was understood from the very beginning. When Newton knew it very well, he did very clever experiments to establish that they are equivalent. So these are the two laws. So primary aim to show that these laws are neither complete nor unrelated. What are the problems with these laws? Generally, we are unaware of about these things. There are problems of this type, ambiguity, problems of this type, the mystery, and also paradox. What are the however, a far more fundamental issue is never taken up for discussion, and in school level, also in college or university level, I have seldom seen this discussion that why only acceleration of a body faces resistance and same is not the case with velocity. There is no reason. Why philosophically can you find any reason that why velocity will not have any resistance whereas acceleration will have, just because you differentiate twice with time? No. At least till today, there is no very clear answer to this. What is the ambiguity associated with these laws? The frame of reference. You all know, you are told, particularly if a teacher is very good and when he teaches you mechanics, that F is equal to mi into A if and only if A is measured in an inertial frame of reference. In most cases, teachers don't bother about this. They say F is equal to ma, solve problems. But I think good teachers and good students are very aware of this thing. Newton also knew that, and generally the most famous book in mechanics, Principia, is the least read book. Nobody reads. But if you go there, you find there is a discussion about this point. And Newton, when he was asked the question, what is an inertial frame? So the answer which was given by Newton is that in which F is equal to MIA is valid. Of course, you realize that if you give this kind of reason in your PhD thesis, that will not be accepted. You will miss the degree. So this circular reasoning is not acceptable in science. So this remains as an ambiguity. And what is the mystery? Mi is equal to equivalent mg. So you all know that equivalence of inertial and gravitational mass. So that is also a mystery. There is no direct, of course, general theory of relativity was started from this point assuming they are equivalent or taking up they are equivalent, but why they are equivalent, that question needs to be answered. And I think according to this gentleman, you all recognize him. There is no clear answer, and he says that this has remained as one of the biggest mystery in mechanics according to this gentleman. So this is the mystery part. Paradox with the gravitational law. So let us consider the universe in very large scale, where it can be considered as uniformly distributed matter, filled up, isotropic and homogeneous. So you can imagine any point in this universe in a very large scale, and imagine another sphere with any radius you like, and then you can conceive of a sphere like this, and suppose there is a particle M, then you know according to the gravitational law, the matter contained within this sphere which you have imagined, this mass will be attracted towards this center by a force. What about the rest of the universe? You can divide it into thin uniform circular cells, the whole rest of the universe. And you also know that a thin uniform circular cell produces no force inside that. So there is none of these cells will produce any force. So ultimately you can show that a mass M here will be attracted by a force F towards this O. But this O could be here, O could be here. So this is absolutely an arbitrary situation. And there are many other forms of gravitational paradox which I will not come here. So this was also recognized by the people, and there are some solutions suggested. One of the solutions which is most logical perhaps is by Laplace. So Laplace said that G, as we find in gravitational law, is not constant to space. So when the distance between two objects increase, the G also drops. Only thing he said, this dropping, this exponential dropping, it should be, exponent should be, cannot be less than 10 raised to minus 4. Then the effect will be noticed in the solar system. But no such effect has been found. So if at all there is a drop of G with the distance, then I think according to Laplace, it has to be less than 10 raised to minus 14. We'll look into it later. If it is so that G is exponentially decaying, then this paradox is gone. So then what happens? Then the thin shell outside, they produce a finite force here. And if you sum up, integrate it, which I have done and I have found, that you will find this force and the rest of the universe's force are exactly equal and opposite, cancelling. And so there is no force as we see and as we expect. So paradox is there. Unless you consider the variation of G with distance, I think this remains as a paradox. And there are other forms of gravitational paradox I will not discuss. So this Laplace's solution was like this, that G varies with distance according to this following equation, and lambda has to be less than 10 raised to minus 14 per meter. Otherwise the effects will be noticed in the solar system body's motion. Now motion, that is acceleration, is absolute or relative. That is another very important point. It is an unsettled debate. It is continuing from Newton's time. Newton considered acceleration is absolute. It is in the space is an absolute frame, and with respect to that, when it accelerates, that is the absolute acceleration. But according to a contemporary philosopher, George Berkeley, he said motion is relative. It cannot be, whether it is acceleration, the interaction between bodies depends only on the relative acceleration. All the dynamical effects you observe are because of interaction of moving bodies with respect to the matter present in the rest of the universe. That means if you kick a football, you get this force, which is nothing but interaction of this acceleration with the rest of the universe's matter. Of course, it is not that this information goes back, far off, and comes back. A field is created throughout that, and what you are interacting with is the field, as it happens in case of electromagnetic. So Newton attempted to prove the absolute nature of motion by his famous bucket experiment. Maybe some of you have heard about it. He said that let there be a bucket half full of water and suspended by a rope. And when it is stationary, no rotation of bucket, no rotation of water, the water surface is flat. Next, what you do? you rotate the bucket. So water is still not picked up the motion, it is still. So you will find bucket is rotating, but water is still and the surface of the water is plane. Then what happens after some time, water also picks up the motion, both the bucket and the water rotates, and then you find the effect of acceleration, inertia force, you find that the surface is inclined or rather curved. Again later when it stops, when the bucket stops, but the water rotates, continues to rotate, then also you find that the surface is curved. With this, Newton wanted to prove that it is the absolute motion of the water that is what is important, not the relative motion with respect to bucket wall and the water body. It's a very naive statement, as you understand, and of course it was not taken up by Berkeley. He said that, the matter contained in this bucket is so little, nothing. If the thickness of this were light years or even billions of light years thick bucket, then nobody knows what would have happened. Perhaps maybe even water is stationary and bucket is rotating, water surface would have been covered. It is the relative motion that would have been important. Here the relative motion is unimportant because the matter contained in the bucket is too small. This was of course not really bothered by people because mechanics was taking care of celestial mechanics so well. People got all these discussions and all these criticisms. But after a long time, the question was resurrected by Mach. This is in 1838 to 1916. And he again, the idea that acceleration between bodies, relative acceleration is important. And what happened, he was lucky because a great scientist like Einstein, who was like almost a disciple to him, he supported his philosophy. And since Einstein became famous, his principle also became famous. Earlier, nobody knew about the whole thing, and it got the name also as Mach's principle, which you might have heard. Mach's principle says that if a matter with some gravitational mass is accelerated, then it interacts with the rest of the matter in the universe which is present, and this interaction produces a force. So inertia, that means this becomes inertia force. So inertia is not an intrinsic property of matter. It is a relational matter. So it is nothing but the manifestation of the relative motion of this body with respect to the matter present in the rest of the universe. That was his suggestion. So when applied to the whole universe, what happens, you will find that a body with a gravitational mass mg, because this interaction is dependent on the gravitational mass. Now if you sum up this interaction of the matter present in the whole universe and integrate, then if you get this total force becomes MIA, then MI and this mg will be equivalent because you started with mg and ultimately you get mg into A, and with that case we say mg is mi, so they are the same thing. So gravitational inertial mass is nothing but the manifestation of gravitational mass in this situation. But does it really happen? So this was not possible to verify because it was in the form of a philosophy. You can give 100 hours lecture with philosophy, but you cannot make a one-line calculation. That is the problem. And to show these things quantitatively, one needed a quantitative relation. So one had to wait till the beginning of the 1950s. This famous Cambridge professor, Dennis Yama, he proposed a quantitative model of Mach's principle in 1953. Have you ever heard of Dennis Yama? 1, 2. How many of you have heard about his student's name? His student is Stephen Hawking. Then the whole class will raise 2 hands. But there is a very interesting experience I had. I was giving this lecture in a small-time college, So when I came here, sometimes you should have some deviations, not a continuous lecture. I asked the same question. I said, have you ever heard about Dennis Yama? He said, no. He said, have you ever heard about his student's name? I said, who is he? He said, Said Stephen Hawking? But no, sir. So he proposed the quantifying Mach's principle. He suggested a rule which he called model of inertial induction. If you have a mass m1, of gravitational mass m1 say, and another gravitational mass m2, and if you accelerate it with rate a, then this will be subjected to a force because of this acceleration, and this force is due to the interaction of this matter with this. Similarly, oppositely, if you keep your finger here and this accelerates, again you feel the same force Fi. This is called inertial induction force, and the gravitational pull will be always there, gm1 m2 I r square, but this will be an extra force due to the relative acceleration. And the magnitude of that he proposed will be g m1 m2 by c square r into a. C is the speed of light. So it is a relativistic effect you can recognize, and he got the idea by comparing this with a similar situation with electrostatic phenomena, Coulomb's law. You know, when there are two charges, they are subject to an attraction just like gravitational attraction, and it has been found that if one accelerates with respect to this, then an additional force also comes down. So he said that if it happens in case of electrostatic phenomena, perhaps a similar law I can assume in case of gravitation also. That way, he proposed an inertial induction with this as the extra force due to relative acceleration between two bodies. Now, the second law of motion from inertial induction. Then, quite a few scientists, including few from Italy, they tried to apply this to the proposed Mach's principle. So they suppose the matter present in the rest of the universe, whole of the observable universe. So if you take any matter contained in a small element of the universe with mass m2, and your mass is m, if you take up this and you sum it up with the whole of observable universe, it becomes something like this. Rho is the mean energy matter density of the universe. D volume is the elemental volume of the universe at a distance r from this. And if you integrate this, then he showed that this becomes approximately 0.1 mm. Now the kind of, and the observable radius he took as c by Hubble constant, c by h. So I think it has been felt by almost everybody that the kind of quantities involved in g, rho, c, then c, the h, then you mixing up all these things, you get something approximately ma, is a reasonably good validation of the basic idea of Mach's principle. Actually, it should have been exactly ma, isn't it? So, but there are two problems then we are facing. One is it is not exactly ma, and the other problem is it is not just exactly ma like this. This cannot be dependent on the fine tuning of all these quantities, that they are such values that the coefficient of this becomes exactly equal to 1. This kind of fine tuning is not very philosophically very acceptable thing. So there must be something which will make it automatically 1. That means a kind of servo mechanism or whatever. That means some feedback must be there. Otherwise you cannot have such exactness in equivalence depending on the fine tuning of the various universal parameters. It is not acceptable philosophically. So now let us look at our universe. Before I proceed further, it has to be understood that how our universe is in a very large scale. So this is the local universe, you know. This distance is 1 million light year. Our Milky Way galaxy is this one. Its diameter, a radius, and diameter is 100,000 light year, you know that. And these are the nearest similar spiral galaxies, Andromeda, at 2 million light year away, you all know that. And these are few other objects. And this is 1 million. If you look at a still larger scale, you make this as 10 million light year. Then these dots are all galaxies, small dots. And this becomes the local group. This becomes the local group, where somewhere This is somewhere our own galaxy is contained. Now, if you go to still larger, this becomes 100 million light years. These are all computer generated things. It is not artist impression. So now then the galaxy, they start to lump up in the form of clouds like this. You all know that. And this is coma. This is all these things are there. But then I think if you go still larger scale, it starts looking like a foam. And if you go to still larger scale, you will not see any structure. And this is again a computer generated plot of 1 million galaxies. It is an old result, early 90s from Princeton. It must have changed now and must become much better. So you can see this is actual plot of 1 million galaxies, what we can see in our observable universe. It looks more or less uniformly distributed. So you don't know if you go to another billion times more size, what is going to happen. My point is that most probably it will look as if it is uniform. So therefore, universe can be considered to be homogeneous, quasi-static, that means things are moving but no overall general motion. We have to consider it to be infinite unless there is proof otherwise. No curvature of space has been noticed so far. That you all know, that it is Euclidean everywhere. And a mean, therefore, in such a situation, a mean rest frame of the universe can be considered. That means you take a huge chunk of the universe and take the center of mass, consider another huge chunk here, take the center of mass, another one. So you can definitely constitute a frame of reference which has absolutely no motion. Otherwise, even today, you can take your microwave background radiation as a frame of reference. And any absolute motion with respect to that can be considered as motion with respect to the mean rest frame of the universe. So therefore, this is important because the point will come very soon. So hence, to apply a quantitative model of Mach's principle, the universe can be assumed to be homogeneous, quasi-static and non-evolving as a whole. All these are actually essential to satisfy what is known as perfect cosmological principle. Then only all these. Now all present observations till now at least it support this, except the lumpiness which may vanish if you go to still much larger scale. Now if we want to get the exactness in the equivalence, you have to extend Mach's principle. Otherwise you have to depend on fine tuning. So a simple model, a detailed model, simple model can be that question I bring again, that if two masses are there and there is a relative motion, then there is an acceleration and also velocity. So there is no reason philosophically that why velocity will not produce any extra force. So let us consider that there is an extra force, just like Sciama's inertial induction, depending on acceleration, there is an extra force or depending on velocity also. So F total force can be the Newton's static gravitation, Sciama's extra inertial induction, and another one we add like this which depends on velocity. So then therefore the total force depends on the distance, the relative velocity and relative acceleration. Of course the distance, etc., they can be all vector things we should consider, but it will be, actually I designed this primarily for class 12 boys and girls, so I didn't go into those detailing. Basic principle can be explained. With this, then if you take a small element of the universe and your mass, which is a gravitational mass of course, you remember that these masses which I showed just now, these are all gravitational masses. So, and then the elemental force due to an elemental part of the universe will become this. And if you integrate it over the whole infinite universe, that means from 0 to R0 to infinity, it becomes like this. This term ultimately vanishes because of symmetry. All sides will be equal. And the rest of the two terms, you can then continue the process. You can show, I will not go into the intervening calculations. Finally, it comes out that the force, total force is equal to exactly ma, and this m is the gravitational mass we have started with, And another term which looks like a drag term, which is a constant kappa into gravitational same mu velocity square by c. This is a term, and in the process of this analysis, g also comes out as an exponentially varying force, as suggested by Laplace, where the lambda, that is a coefficient here, is kappa by c, and kappa comes out as pi g0 into rho. G0 is the local value of g, and rho is the average mass energy density of the universe, this, and it is 1.2 into 10 raised to minus 18 per second. So you can see this is equal to minus 18, 10 raised to minus 18 by c. C is 10 to the power 8. So therefore it becomes something like 10 to the power minus 26. So therefore it is very small and not detectable by any means, at least with our present day technology. Now if you, so therefore with this slight extension of Mach's principle, this quantity, the force law becomes slightly modified. It comes as a drag, which may be considered as a cosmic drag, and the Newton's second law, where this no fine tuning is necessary. You can take any value of rho, c, etc., you will find this coefficient is exactly 1. So therefore, law of motion is actually speaking not a law. It can be derived. Anything which you can derive is not a law. So therefore, it is a modified form of Newton's law you can consider is equal to this. So that, of course, takes care of few things, like gravitational paradox is gone because g is not constant, varying exponentially. Exactness of the gravitational and inertial mass comes automatically. And of course, the inertial frame problem we solve by considering a mean rest frame of the universe. Now the question is, these general results, as we just said, exists. The force law is derived from interaction, establishing balance, and the gravitational constant decreases exponentially. The paradox is removed. So the three problems we started with, they are at least taken care of. Now the question is, acceleration now does not enjoy any special status. Velocity also gets resisted. Only thing, the difference is in their magnitude. Acceleration, so that way you know there are many phenomena where the relative magnitudes are very different. Like if you take gravitational force and electromagnetic force or electrostatic force, you know they are drastically different in their magnitude. Had it not been so, I think it would have been very difficult for us to separate the two things. Gravitation is so weak, we can see its effect only because the electrically charged objects, they neutralize because of positive, negative. And I think you all know, I think I will not go into the what is different, 10 raised to 40 or what, the ratio between, I think, Somnath, between two electrons, they are electron and positron, proton, their attractive force and their gravitational force, I think order is 10 raised to 40, something like that. Something. It's enormous. You see, wonderful. You are a student here or from school? 11, wonderful. See the real audience I wanted to be. And furthermore, inertia is not an intrinsic property of matter as told by Newton, but it is the manifestation of dynamic gravitational interaction of a body with the rest of the universe. Now you see, it is fine. This extremely small cosmic drag which comes out here, can it be observationally detected? Now to detect it, we have to consider those objects which travels at the fastest possible speed, that is light, and which travels the longest possible distance. Where do you find such light? Light coming from the distant galaxies. So let us consider what happens to a photon coming from a distant galaxy and reaches our eyes using this cosmic drag. Now before that, of course, since she is there, I will tell this. Otherwise, had it been our IIT audience, I need not have done this. So if there is a photon of source, the wavelength is lambda, when it goes to the target or the eye or any observing instrument, its wavelength may be elongated to this, then what happens? This quantity, the increase in the wavelength divided by the original wavelength, this ratio which has a common symbol Z is called redshift. Why redshift? Because if the wavelength increases, means it is becoming reddened. In Bengali it is called lohita posaron. Redshift can be all produced by two methods. One method is that if some object is receding from you, then you can easily prove that the wavelength which is generated there, source, it will reach you, it will appear to be elongated. That is called Doppler effect. You know, it happens in case of sound and you observe it. Unfortunately, Kharagpur station is big and no train crosses past Zoom. But go to a small station like Balichak, you can see that. So, let us consider a photon. We started from a star in a distant galaxy at a distance x. It is here. It is moving with a speed c, because light speed is constant. Energy is h into nu. H is Planck's constant, nu is the frequency. Frequency is what? C by lambda. Now what happens? Since it has this energy, you can find out its mass by Einstein's equation, E is equal to mc square. So you divide this by c square, it becomes the mass. And you apply this velocity-dependent inertial induction model we propose, you will find the photon energy is subject to a cosmic drag. You can easily see it, just two-line calculation. Hence, the drop in energy because of this drag, when it moves by a distance dx, will be this. So d is equal to minus, that is a drop, this. And solving this simple differential equation, you can show that nu by nu 0 is the frequency at start, it becomes e to the power minus kappa by c into r when it reaches here. And so therefore, the redshift approximately, because if this is very small compared to 1, kappa is so small, kappa by c becomes 10 raised to minus 26. So generally, it will be much smaller in most cases. So therefore, you can make this assumption. But even if it is not assumed, there is no problem, because in the very large scale, redshift it doesn't follow Hubble's line is not a strict state. You know that. So this redshift Z is approximately equal to kappa by c into x. So kappa by c is nothing but Hubble constant. Or rather, kappa is nothing but Hubble constant, because Hubble constant you have to multiply this by c to get the velocity of recession, equivalent velocity of recession, what you consider that galaxies are receding with that velocity. So if you multiply this quantity by c, the speed, then you will find this the speed with which it must move to have the same redshift, which we consider as assumed Doppler effect. So Z is equal to kappa by c into r. So if you plot it, or the exact expression will be Z is equal to e to the power this minus 1. The exact, if you do the plotting, so these are the observed values of the redshift of the distant galaxies. There are better curves these days because this is somewhat older. And this is red line is the plot. So therefore, this completely theoretically obtained redshift, no observation except the average density of the universe, that is the only thing which you have considered. You will find that this result is quite interesting, that without using any observable thing about the expansion or any such hypothesis, you get a redshift which matches the observation. So therefore, no need for, if it is true, then you did not consider expansion, because why expansion has come? Even Hubble, when he first gave the law, it was not expansion. His diagram was redshift versus distance, not velocity versus distance. Later it has been multiplied by c and it has been made equivalent velocity of recession, because there is no other mechanism by which you can generate redshift in this manner. So the first test, this clears this proposed thing. So observed redshift of light coming from distant galaxies are redshifted due to the loss of light, which may be considered as a tired light model. And no expansion is there. Of course, people will try to kill me if I say this, physics community definitely. And of course, if there is no expansion, there is no Big Bang also. Because Big Bang was, it was proposed as a joke by Fred Hoyle. You all know that. Now, I think the important thing here is that there is no adjustable, free adjustable parameter. G0 value you cannot manipulate and tinker with. Value of C you cannot tinker with. This is the only thing which you can change, but I think that also depends on the observation. You cannot tinker with. But a new theory needs to be verified in as many unconnected situations as possible. This is just one. You have removed the three problems and you have shown that the existence of cosmological redshift as an outcome of this. But I think such a new thing did not be accepted just because of that. But the effect is extremely small for verification in laboratory. I have suggested one, and maybe Soumitra at ISR is doing it. We have a special type of Michelson-Morley experiment with one wing horizontal and one wing vertical. There the effect can be found out. Why it cannot be found out by a falling photon type of experiment is that when it falls, a photon comes down, it is blue shifted due to gravity. And when it goes up, it is red shifted because of the gravitational pull. So total result, if you get, and if you take the difference, the general error gets cancelled, only the minus and plus gets added. So the Rebka's experiment was a two-way experiment. In one direction, the redshift was 16 into 10 raised to minus 15. And while coming down, it was 12 into 10 raised to minus 15. So they subtracted, and they got 4 into 10 raised to minus 15. Divided by 2, they got 2 into 10 raised to minus 15, which is the answer. But if this kind of a gravitational drag is there, so it will be redshift while coming down, while going up, and that gets cancelled. You cannot find out this by any two-way experiment. You need a one-way experiment. Now, I think let us see if this can be applied to some local bodies and we can see its effect. So, there can be two types of experiments or observation. One is interaction of light with matter and interaction of matter with matter. This effect should be present in all cases. So, photon-matter interaction, if we take, there are certain possibilities. This photon-matter interaction is of local nature, not universal nature. So, you see, there is one phenomena actually that when a photon goes away from a big star, there is a gravitational pull and it causes redshift. This is called gravitational redshift. Einstein gave his answer also, G m by c square r. You are all familiar with that. But I think so therefore the redshift will be this, which was given by Einstein. Now, if this inertial drag is also present, then you will find this will be elongated further. That means there are two effects. So what happens that if you measure the redshift and consider only this model, what will happen? M will tend to become larger, isn't it? Whereas if the total redshift you measure and you consider the combined model, then you will find M will become less. Now this problem, actually it has created a problem in a mass discrepancy in white dwarfs. White dwarfs are compact stars, very large density, where the redshift due to gravitational pull is very large compared to sun and other stars. And it has been found, actually in this case, Z is equal to this. In this case, actually it is 1.67. So if you consider this is equal to G0 m by c square r, this m will become 1.67 times more than the actual mass. So in white dwarfs, it was found that the mass which is measured by conventional theory using the redshift, you can use that. And when the proposed theory is used, this will be Z, and so conventional theory mass will be equal to Z, measured Z into this, and modified theory mass will be 3/5 by Z into c square r by G. Let us see that results of the experiments or observations. Large number of observations were done by Virginia, Trimble, and Greenstein. So they showed that these kinds of method by which they measure the mass, photometry, binary star method, two-color diagram, I don't understand myself. 240 experiments they did, and average mass of a white dwarf came as approximately 50% of a sun's mass, solar mass. But if you do the same experiment using the gravitational redshift, the average mass of the comes as 80% of solar mass. So this discrepancy was not possible to solve. But if you consider the presence of this gravitational drag, then again you will find even by this method your average mass comes as half the mass. So this discrepancy can be resolved if you consider the modified theory. So this white dwarf mass discrepancy was there. Then Narlikar suggested that you apply this to photons grazing huge bodies. In a normal situation, what happens? The gravitational attraction causes a blue shift of the photon, energy increases, and when it recedes, then there is pullback, so it is a red shift. So finally, it comes with zero extra red shift. No change. But if there is this kind of a drag, so then while it is approaching, it is pushed back by the drag, and when it is receding, also it is pulled back. So that will produce a resultant redshift. But conventional theory will not produce any resultant redshift. And this redshift has been calculated theoretically. It comes like this, and the values are like this. Typical star like sun, this resultant redshift for a grazing photon will be 10 raised to minus 6. Conventional theory cannot produce any such thing because potential here and potential here are the same. There will be no resultant redshift. Now you see the observation. You know, one experiment was done long back, 1968, when there was some total solar eclipse. Then a particular star, Taurus A, was close, approaching sun, and it was found it came closest was, I think, 5 solar radii, and approximately 10 raised to minus 7 was an excess redshift of that star. Again, when it went away from this solar disk, again there was no excess redshift. A similar thing was found in case of Pioneer 6. It is an artificial spacecraft which was sent on some mission, and for some time it went behind the solar disk. There it was found that when it was approaching solar disk and when it was approaching the sun's radius like this, it was becoming approximately 10 raised to minus 6 or something like that. Again, when it crossed solar disk, again that excess redshift went down and it became 0. So this kind of excess redshift of photons, whether it is light or electromagnetic wave, you know, they are the same thing. That is found to be present as expected in this case, but not in conventional theory. You can explain this. They try to explain it with many things, gas pressure, this, that, I don't understand myself. There is another case where a huge number of experiments were done in India. You know, there was one very famous astronomer who worked in India for a long time. Do you know his name? In Evershed, you know. So the solar astronomy, he is the father of that, and he worked primarily in India, because in India you find sun not in so clear, much better. So he showed by large number of experiments that when a photon starts from when you see the solar disk, from the middle of the solar disk, and when you see from the limb, that is periphery, the spectrum are different, and he showed that these yellow dots are Evershed's experiments. You find that actually they are minimum here, and as you go towards the rim, it becomes more, and near at rim, it is much more than the theoretical value of Einstein. So this has not been possible to explain that why it is there. If you apply this modified rule, you can show that the redshift of, if you measure from the solar disk from center to limb, it will be this red line. And it matches very well, and it explains this excess redshift in the solar limb, which otherwise there is no conventional explanation. The variation, here you find that why this variation, it is because of the granular effect. Matter present in the sun is not static. It is always coming up like a bubble, then they spread and come down. So what you see, this effect of the approaching velocity is there, that's why there is a blue shift and it is reduced. But as you go to the rim, that the velocity or bubble velocity will be perpendicular to your direction, and it should not have any effect on the redshift you find. It should be exactly equal to Einstein's value, but it is much more than Einstein's. So 3 local experiments with light matter interaction give correct result. And no case you find there is any free adjustable parameter, I can take this value as this. Not possible. Only 3 quantities are C, rho, and G0. Now let us go to the other cases where matter-matter interaction. A very interesting result we find. So you see, if there is a central mass of spinning like Earth and an orbiting object like a moon, what happens, the angular momentum of this cannot be transferred to this according to conventional theory unless you develop some mechanism. So whatever angular momentum it had will continue to spin with that. Whatever orbital angular momentum it has, it will continue with that. But suppose you take this effect which you have suggested, this body is spinning, so a particle on this body is trying to recede from this orbiting satellite. So this will be subjected to a force, this will be subjected to a force. This one is approaching because it is rotating like this. So this will be pushed back and this will be pushed back. So this will be subjected to a resultant force and this will be subject to a resultant resisting. It is only because of this assumed velocity dependent inertial induction. So this will gain in angular momentum and this will lose. Total angular momentum will remain same. So this transfer of angular momentum from a spinning body to an orbiting body is not possible in conventional mechanism unless there is some physical contact. So let us consider Earth because we have some data. You know that Earth is spinning 24 hours one day, but this rate is slowly reducing. The rate at which it is decelerating, that is omega dot, is 6 into 10 raised to minus 22 radian per second square. Mistake to minus. So that is the angular deceleration. This has been established pretty well. Conventional explanation is also found in book, which of course nowadays people have discarded, but this continues to be there in textbook. That is the funny thing. It is a mechanism of tidal friction. So there is an ocean tide, there is a bulge due to the moon. So what happens? This bulge, elliptic bulge due to tidal phenomena, due to the moon's gravitational attraction, is locked with the moon's position. So if this spins, Earth is spinning, but this bulge remains relatively, it is also rotating because of moon, but that rotational speed is much less. Almost 30 days it takes, but it takes only 1 day. So there is a relative motion between this bulge of the tidal water body and the solid Earth, and that causes friction and a torque. You cannot calculate, there is no way you can calculate that torque. You can only assume that there is a torque. And what happens? Why this is gaining? Because of this torque on the Earth is like this, torque on this elliptic water body will be in the opposite direction, so it will be slightly shifted like this. Major axis will be like this. And this produces a horizontal component or tangential component of force, which increases the angular orbital momentum of the object. So, according to this, there is a possibility of transfer of angular momentum, no doubt. But as it gains angular momentum through this mechanism, it will also recede further. In orbital mechanics, anything gaining angular momentum also recedes. So, it should have receded. So, and through calculation it has been found that 1,000 million years ago, moon must have been much nearer. And so near that both the two bodies would have been destroyed because of the nearness of mutual gravitational pull, that is called Rossel image. But it has been found through sedimentological evidence that tidal phenomena was present for 3,000 million years. But there was no question of any destruction of the two bodies. Not only that, even the tidal phenomena was not very strong. Strength of tide is inversely proportional to the distance to the power 6. So distance to the power 3. So if the distance was half, the strength of the tidal phenomena should have been 8 times. But there was no such effect. It is just normal tide phenomena is there for 3,000 million years. So that's why the real experts have discarded this tidal phenomena. It cannot explain the phenomena. Now let us do one thing. Let us consider when the earth is spinning, it is spinning with respect to sun's body, it is also spinning with respect to moon's body. So they are using this velocity dependent inertial induction, there will be a torque on earth due to the presence of the moon and also a torque on earth due to the presence of sun. The presence of the moon, its mass is so small that torque is very small compared to that due to sun. So you can ignore that and consider the sun's. So if you do it, every particle on the earth will be subjected to, if it is rotating like this, sun is this, so therefore this sun will push it off, and here it is going in that direction, sun will pull. So if you integrate over the whole earth, taking its density variation, everything, you will find that there is a torque due to the presence of suns and relative motion of the particles with respect to sun's mass. And you can easily theoretically calculate this torque. It is unlike your tidal phenomena. Here, since the data is known, density variation, everything, size, distance, so you can theoretically calculate the torque, and this inertial induction torque on the earth becomes 4.75 into 10 raised to 16 Newton meter. And if you divide this by moment of inertia of the earth, which is also known, then you get a retardation 5.5 into 10 raised to minus 22. You see, it is approaching very much 6, slightly less. It is because tidal phenomena will produce some deceleration, no doubt, because it is present. It cannot take care of the whole of it. Rather, it takes care of only very small fraction. This phenomena removes this close approach problem of the moon. Because close approach, there the whole angular momentum was of the earth, which it was losing, was being picked up by moon. In this case, it is not so. It is being influenced by the sun, not by the moon. Moon is influencing only a very small fraction. 1/12 of the effect is due to moon. So that problem is solved. And the value you get, you see, without tinkering any value with G0, rho, and C, you see, instead of 6 into 10 raised to minus 22 radian per second, we get 5.5. And another method which can be, the data is not very clear. If you can find out from this kind of paleosedimentological data, that days per month and days per year, both can be found out, and the geologists have done it, which is a wonder. So if you plot the days per year versus days per month, these experimental values are like this. This is the theoretical value which you will get if you take only tidal phenomena. If you use this inertial induction model, it will be something like this, which is much nearer, though not exact. Test of the tidal theory of Earth's secular retardation by comparing this plot, as I told you, it doesn't match the conventional theory. Let us go to Mars. Mars has two satellites, Phobos and Deimos. Mars also takes approximately 24 hours. Phobos takes only 4 hours or something, I don't know. So Phobos is rotating with respect to Mars much faster. So here, what will happen? It will lose angular momentum because this is rotating faster. So angular momentum of this will be lost due to drag. And you can easily calculate it. Because it is much faster, Mars is rotating at a slow rate, so this will be subjected to a drag, not a pull. And so it will lose angular momentum, and that has been found out. The orbital speed, the rate at which it decreases, approximately 0.6 into 10 raised to minus 3 degree per year square. It's a very large value in astronomical sense. And the theoretically calculated value is approximately 0.5 into 10 raised to minus 3 degree per year square. Again, the matching is definitely noticeable. If you do it for Deimos, the value we get theoretically is approximately 5 into 10 raised to minus 23 radian per second square. And the observed value is 2.5 into 10 raised to minus 23 plus minus 6 into 10 raised to minus. It's a huge band. So this falls very much in that. But it is extremely difficult to theoretically or observationally find out the rate at which the orbital speed of Deimos is changing. And recently it has been also done in case of an Earth satellite LAGEOS. You all know that. It's a geological satellite, and it is tracked by laser beam, and very accurate observation is possible. For 30 years it has been observed, and it has been found that 1 millimeter per day its orbital radius is decreasing every day. Now it has been very difficult to explain all of it. Few effects are there, but only a part can be explained. If you apply this model, it takes care of 30 to 40% of this effect. Half of it is explained because of this. It has been also found that our astronomical unit, which is the distance between Earth and Sun, is slowly increasing. But there is no mechanism for it. Some people have tried to suggest that it is due to the universal expansion. But if you apply the same rate, then it should also match, if it is due to universal expansion, the distance between Sun and Jupiter, distance between Sun and Saturn, they should increase also at a much faster rate, but it is not happening. Rather, it is the Earth which is increasing at a much faster rate. So it can be theoretically, we have applied this model, and we found that in place of 12 millimeter per century kind of thing, I don't remember, we got 9. And one interesting thing I will tell here before I end, the Sun using the theory produces a secular retardation of spin of Mars. You see, just as Earth we have found it has about 5.5 10 raised to minus 22 radian per second. If you apply the same model in case of Mars, you will find Mars should also have this secular retardation like this. But nobody has ever measured it because nobody ever suspected it. Because Mars doesn't have so much of water, big moon like our moon to absorb the angular momentum. There is only a speck of dust, Phobos and Deimos. They cannot pick up the angular momentum from the Mars. If it does, then it will go out of the solar system with that kind of angular momentum. So, if it can be found by NASA, and there is one experiment, I had long discussion with them, if they can do it, then of course there is no explanation. Tidal theory doesn't work here. Even if solid bodies produce tidal, you know that, geologists will tell you, but Phobos and Deimos doesn't have enough size to absorb that angular momentum. And another problem I'll tell, and we'll finish the talk. It is our Sun and the solar system. Sun has 99% of the matter contained in the whole solar system. 99.9% of the matter. But only 0.5% of the angular momentum. So this is not possible unless, because the whole thing was formed through the condensation of a galactic, part of a galactic cloud. So this was the part of the rotating galaxy which started contracting due to its mutual gravitation, and gradually it took, after 10 days to 6 years, a protoplanetary disk was there and approximate the spherical shape of the central body, and as it becomes smaller and smaller and smaller, angular momentum is constant, but the moment of inertia is reducing, so they will rotate at a much faster speed. You have seen the circus that when the lady rotates like this, and when takes the hand like that, they rotate much faster. Same thing. And with that fast speed, the equatorial region will be thrown out and form the protoplanetary disk, about 10 days to 6 years. Then it gets further. Then after 10 days to 7 years, because it becomes hotter and hotter, then its temperature reaches the enough high value to start the nucleosynthesis. So this 10 days to 7 years after that, nucleosynthesis starts and it enters the main sequence. Then it becomes stable. Radiation pressure will not allow it to contract further. Enough energy is there, and it will continue to remain so. And during that part, this protoplanetary disk, it condenses and forms the various planets. That's why all the planets you find on the plane of the ecliptic, in one plane. And this main sequence period, what happened, when it starts huge radiation of this nuclear reaction, it completely cleans the whole environment, almost sweeps the dirt and all the things. So it becomes a much cleaner system as we have it today. But this period is very long. It is 5 into 10 raised to 9 years. So now the question is, so therefore the original angular momentum should have been all contained in this matter, which is 99.9% of this. Where is that? Only 0.5% is left. 99.5% has gone. So everybody now realizes that it must have been transferred to the bodies which are orbiting. But how it has happened? You cannot transfer angular momentum. So there is work done by Hoyle. So he showed by some assumptions that during this process, when the nuclear reaction starts, it was very strong, and the electromagnetic lines of forces, the solar wind, etc., they acted as spokes and could physically transfer the angular momentum. And angular momentum was transferred because of this. But after it got cleaned, there is no mechanism. So, but if you apply this mechanism and theoretically calculate the present value of angular momentum of the sun, you get, we start with the Hoyle's values. So this is the original angular momentum of the original cloud. Mass of the detached disk was 2% as estimated from the existing evidences and used by Hoyle. The present solar angular momentum comes as this, theoretically, observationally. When a transfer mechanism based on inertial induction is considered, you get this. Also very near to this. So it reduced from this to this, theoretically, and observationally the value of this. And there is another phenomenon which is important. You see, if this angular momentum gets transferred in a short period here, then here all the angular momentum is transferred and this sun starts rotating slowly. But in this mechanism, most of the angular momentum was lost in this long period of 10 raised to 9 years. So only when after it has spent, because it is always present and active, only after this long period it will be rotating slowly. And observationally it has been found all newborn stars rotate very fast, and these stars which are very old, they rotate slow. But according to this, all stars should have been slowly rotating. Then I think it was applied to Pioneer anomaly. It explained this and other kinds of anomalies also. And also the rotation curve of the spiral galaxies, then the dark matter, etc. That problem is also taken care of, removed. Only thing, all these very different things, they are giving reasonably good result, but without any free adjustable parameter. There are only 3 quantities you can have at your disposal. So, model of the universe is infinite, non-evolving, and non-expanding, satisfying the perfect cosmological principle. If you take the universal interaction, you get exact equivalence of gravitational inertial mass, no ambiguity about frame of reference, no gravitational paradox. Law of motion is modified, a small cosmic drag acts on all bodies, and cosmic drag produces the cosmological redshift almost exactly, and no need of dark matter. That I have not gone because time is short, but it has been also shown. And with the local interaction, the excess redshift of photons, excess redshift of photons grazing massive bodies, as experiment suggested by Narlikar, it works. Excess redshift at the solar limb also explained. Mass discrepancy of white dwarf stars resolved, and a mechanism of angular momentum transfer without any physical contact. It explains these things. And mass distribution in spiral galaxies, there is a very peculiar kind of flat rotation curve you get. That also gets explained by this model, which I have not discussed here. So therefore, the important thing is that the secular change in the spin rate of the planet Mars, if it is detected, then again there will be a strong support in favor of this model, because there is no other way to explain. In case of Earth, the conventional theory at least has the advantage of a moon and an ocean and all those things. So planet Mars, you all know, played a very important role in deciding about the model of our solar system from our earlier geocentric system. You all know Kepler's work. He was the person who could find out the elliptic orbit only by examining the planet Mars. So maybe if you examine planet Mars again with higher technology, It can help us to decide what should be the nature of our universe. So some of the references I give here. And I think this whole thing was examined long back, I think 1990 sometime by Professor Amal Roy Choudhury. There was one Professor Vishesharaya in Raman Research Institute. He sent all the publications. So Amal Roy Choudhury called me and told me, Amitabh, I think fine, there is definitely very strong physics in all this, but you are not able to decipher that. I said, definitely not. I am not a physicist. Another very interesting thing I have not told, that is a very surprising result. You know, if you consider a particular object of mass m, its gravitational potential energy becomes minus mc square. So mass energy is mc square and gravitational potential energy is minus mc square. If you add, there is almost nothing. Thank you very much. If you have any question, I'll try to answer. Yes, that work on Lagios was done by the tech project. You know, they applied the whole thing to Lagios satellite and found out. Another work is there which is going to be published, that is on the Earth, Moon, Sun dynamics, and they found out the gradual increase of the astronomical unit, as I mentioned. That is also a work done by the students.